Welcome again at this Smart Industry talk on data. In this talk I'll talk more about data collection, why we are doing it and what kind of data we collect. In this smart industry environment, or Industry 4.0 as you would call it, we see these kind of ambitions of going for zero defects, all these kind of things, which actually need a lot of data. I/O systems, collecting data, using it in control, sometimes for tracing, all these kind of things. And the data collection is possible these days. What we saw initially with hard-coded control, with camshelves and things like that, became in the 60s really the PLCs, and the 70s and the 80s, of course, PLCs, in which there was a one-to-one relation on inputs, outputs. What we saw gradually doing is that we collect more data, more inputs, and even we today have situations that we have 100 inputs for only one output. In this slide here, you see that for those situations you use these industrial Internet of Things computers or edge computers, where you really have a lot of processing power close to the processes where you can deal with them. In this particular case, the PLC you see is RaspberryPi PLC, just running on the Linux systems, which you can program yourself with programs like Python, but even C if you want. Why am I explaining it? Well, with all the data we start collecting, you have to store it, and once you store it, you have to clean it, then you have to start analyzing it, monitoring it, visualization of it, and later on you want to do it in simple control systems, and ultimately is this big thing of artificial intelligence. My warning is with AI, it's a steep learning curve, and I'll get back on it in the next videos. But for now, it's about handling, collecting, and visualization of the data. All these kind of devices you can represent in these control systems is what we call a digital twin, in which as a sensor, it's quite often the particular physical thing you want to measure, temperature, or whether an input is on or off. But at a higher level, those combined in and outputs can become a more virtual status. The reason of promoting this OpenCUA is that it is not just an equipment interface with a message protocol, but underneath it, it's also an object tree. And that object tree described in XML also allows you easier to start using those digital twins, or what the Germans call Verwaltungsschale or administrative shell. What you see in this particular picture is that I try to explain that it's pretty easy to start with these systems already with not too much cost, because you can use open systems. And my advice is, although 10 years ago I would doubt it, but now even in production environments you definitely can use open source systems. And that's not only on the visualization programming, the monitoring programs which are available, it's the software, the Linux environments with the Pythons, with all the libraries on it. In the picture I just showed you, you saw that there was this layer of, with on the top of course the engineering or the office environment, and below it the production line. There's a little warning. Once you start collecting sensor data, I/O data is not copyright protected. So you need to protect all that kind of equipment which you will start in the nearby future to collect a lot of data out of it, that it is not an open door for hackers to get into it. The way you do it is actually you create subnets for every production line, or even sometimes equipment, and put a firewall on top of it. A firewall blocking all incoming traffic and all outgoing traffic except for an OpenCUA. No USB, no Wi-Fi, all these kind of things to make them safe. Especially because it is not an office system. If there are really human life at risk, if it is being hacked, you have to put a lot of effort into your cyber security. But once you have done it and you have collected all the kind of data, you have to store it, and you have to think through what kind of storage you are going to use. It's not that simple that you just put it on a cloud system. No, you have to make a structure for it. I show that in this particular picture. What you see in here at the bottom side is really your production line with the computing interfaces, the firewall to it, and then it goes into your existing logistics and manufacturing execution systems, manufacturing resource planning systems. And actually, you start storing all the information on the product and the different products you produce in this digital twin. Because later on, when it is out in the market, you really start collecting as well. And it is not only out in the market that you have to have these interfaces and start storing things. Also, at this moment, you have that supply chain. Now, quite often these supply chains are not that simple. A bill of material is being exploded into all kinds of subcomponents, and even the subcomponents can be delivered by different suppliers. And from those suppliers, you also want to collect all the data on it. And why is the manufacturing industry really becoming so data-driven? Whereas quite often the focus is still on the physical goods being produced. Well, realize the following. If you did produce a product and you start selling it, quite often you had some beta test users who gave you some feedback, and maybe service personnel out in the field gave you later on a little bit feedback to improve the product. But once you make these products smart, in the sense that there is embedded computing systems in it, like this Internet of Things or industrial Internet of Things, you can start collecting data on all your products out in the market. And realize there is a lot of data collected during production already, the design, the production data. But it is an explosion of data once you start collecting it out of the market, what's happening there. And then, what do we do with the data? How does it look like? This is an example of the PLC, or this is the Raspberry Pi version of it, with just a €100 kind of configuration. This is about €500. And what you start learning is a little bit, collect some data points and start making these graphs. But if you then start, this is the server example, and here, what you see here is actually that there is a file and printed the timestamp and the format of the temperature which is being measured here. This is an output file produced by this program above. With this file, you first probably want to experiment with Excel. You can start importing it. So in Excel, you use the import function. It's a comma-separated file. You import it. Took some experimentation before I really got it right. But to get the data, in this particular case, I have to put the delimiters at the proper way. In this case, I use the comma and not the tabs. I also had, in this particular case, this is a date information on it. And this is what you have in here. Now I need to put something on advanced because of the 0 and the comma, because the decimal separated in my case was written as a point and the thousand is not used. So, and this takes some time before you really have the settings well, and then you can get this particular data. Now the nice thing with Excel is that you can immediately almost generate a chart with it. Let's see, the easiest way is I'll just take this part and insert a line drawing. And here you have this. This is a Python environment. This is again the table as we have it here. And it is Python program. And now I have to admit, it took me a day before I really got it this simple. If you start this program, for example, I'll start it here. This is the graph it makes out of this table. It's pretty simple actually. The nice thing about this Python environment is really that you can also use debugging mode. If you would go to debugger mode and set the debugger here and start the program again, what you see here is that it is really processing it, and then it has this data frame, in this particular case with PyCharm. You can just see how such a data structure looks like. If I come back to this one, it's not so difficult to generate this comma-separated file. With Excel, if you are just experimenting with it, you can have fast tests. You do it, of course, by hand, the import, and as I showed. If you then start using more data and larger files, of course, it could be of interest to start using Python and learn to program in Python. The reason I'm suggesting to use Python is because this data analysis with Python really goes easy, after some initial training, of course. This is, for example, a situation after 3 days measuring the temperature on 8 different points. You get something like this, and this is already 20,000 data points. By that time, you really want to go with more advanced tools. What you also can do is sometimes use a data visualization program. In this particular case, Node-RED I've used here. In Node-RED, what you do really is you program these different components in it. Here I used a weather source, just a public weather source on the internet where they generate a comma-separated file. I processed it or split it really into a temperature one and a humidity. And then with the right graphics, in this particular case, I use these dials you can just program it. Coming back on data in manufacturing environment. Well, data collecting, handling, using it was a little bit the domain of the finance department. And that required a kind of people who are precise, who have some interest in numbers and really can deal with it. The thing on the shop floor was that the focus was all on the physical goods and the logistics around it. But the warning I have is that it is more and more going to be also important to manage all the data on the factory floor. And that means in practice that you need to have more digital skills in the operational environments. So this is video already, but what I really suggest that you start gradually acquire more and more data analysis skills on collecting, handling, playing with the Excel as I did, and finally visualization on it. Warning is start with simple things. Don't be overwhelmed by all the success stories of others. They also started simple. So gain experience yourself with simple cases where you can see the results immediately, and only then expand to more advanced things. Of course, when you start expanding, you have to deal with the legal stuff, the cybersecurity aspects, the Python programming, all these kind of things. And people will start suggesting that you have to do things on AI. Well, AI has an extremely steep learning curve. So first start getting your basics right. Some of the basics was in the previous Smart Industry Data Talks. In due time, we'll start publishing also a few on artificial intelligence applications, simple ones for industrial use. Thank you for your attention.